Welcome to all of you. In this session, we are going to understand the linear convolution in frequency domain using the Scilab. So first let us go through the theoretical view of this linear convolution in frequency domain, and then we'll go through the program using the Scilab. So let us first go through the steps. So given the sequences x of n and h of n, first step, calculate the output sequence length n given by n is equal to length of x of n plus length of h of n minus 1. Then make up the length of x of n to n by inserting zeros at the end of the sequence. Then make up the length of h of n to n by inserting zeros at the end of the sequence. Then apply endpoint DFT to x of n to obtain x of k. Apply endpoint DFT to h of n to obtain h of k. Multiply the sequences x of k and h of k to obtain y of k. The last step, apply inverse DFT to y of k in order to obtain the sequence y of m. And this y of m will have the length n, and it is the linearly convolved sequence of x of n and h of n. Now let us consider an example problem for this. Find the linear convolution of the sequence x of n equals 1, 2 and the system having the impulse response h of n equals 3, 4, 5. In both the sequences, we are considering the first element itself is going to be the origin. So getting into the solution, first identify the length of the given sequences. Length of x of n is equal to 2, length of h of n is equal to 3. Getting into the first step, calculate the output sequence length, that is n is equal to length of x of n plus length of h of n minus 1. That is 2 plus 3 minus 1, that is the 4. So this is the length of the output sequence that is required for us. Now second step, make up the length of x of n to n by inserting zeros at the end. Now the capital letter N is having the length 4, whereas length of x of n is equal to 2. Therefore, in order to make the sequence length x of n is equal to 4, we need to put 2 zeros at the end, and that has been shown over here. Now the length of x of n now becomes equal to 4, which is same as that of the capital letter N. Similarly, it has been done for h of n by putting a 0 at the end of the sequence. Next step, apply endpoint DFT to x of n to obtain x of k. So we are going to make use of this 4-point DFT calculation over here in the matrix method, and we have obtained the sequence x of k. Similarly, it has been done for h of n to obtain h of k, and these were the sequence values we are going to have. Now multiply the sequence x of k and h of k in order to obtain y of k. So these two sequences are multiplied and we have got y of k. Now apply the inverse transform to y of k in order to obtain the y of m. So inverse transform procedure has been done over here, and we have got the sequence y of m as 3, 10, 13, 10. Identify the length of the sequence, it is equal to 4. So as per the starting point, we have calculated the output sequence length 4. So here is the output sequence length 4 we have got, and in order to identify the origin, we are going to make use of this representation. So starting index in the x, that's the location of the first element in the x plus the location of the first element in the h is what the location of the first element in the result y of m. So in this case, we have considered first element itself is the origin. Therefore, in the output also, the first element is going to be the origin. Now let us go through the Scilab program for this one. In the Scilab program, first we are going to read the input sequences. x as well as the h. So then after we are going to calculate the length of these two sequences, then calculate the output sequence length, then make the length of the sequence x equal to n by inserting zeros to that one. The same has been done for h also. Then after calculate the DFT for x, calculate the DFT for h. So we have got xk and hk respectively. Then multiply those two sequences in order to get the yk. Now apply inverse transform for yk so that we can get the sequence y, where y is the linearly convolved sequence. Then after display all those values. Along with that, we are going to make the plot of all the values, that is the input x, then input h, and then the output sequence y for this one. Now let us run this program. Now here we have to give the input. So 1, 2, then for the sequence h, 3, 4, 5 we are going to provide. Now this is what the solution we are going to have. Right, these are the input sequences that we had given after putting zeros. So this is the sequence x and this is the sequence h we are going to have. Then after the DFT for the sequence x, the answer, DFT for the sequence h is the answer. Then after multiplying these two sequences, this is what the answer yk we are going to get. Applying the inverse DFT for this one, the final linearly convolved sequence is what we are going to get. Now drawing the graph for this one or plotting the same, we are going to have the representation over here. So this is x of n, this is h of n, and this is the final sequence y of n we are going to have. Thanks for watching.